good afternoon. Harnessing the power of event-driven systems. That's, of course, a title that you can basically talk about anything. And I guess my abstract was just two sentences more. So I'm guessing that a lot of you have different expectations of what you're going to see in the talk. If you have any questions, don't hesitate to drop them at the end. So my name is Allard Buijze. I'm the founder and CTO of Axon, and I started a journey around 11 years ago to basically experiment a bit with CQRS and event sourcing and domain-driven design. And you could say that that is a little hobby that got out of control. And 3.5 years ago, I founded Axon, and right now we are a team of 30 building software to make event-driven systems more approachable or accessible to the masses, I would say. But before that, I want to go back a few years, few days, maybe a few minutes, depending on your background. But there was a time where it was a really good idea, or it was the best practice to build a so-called a layered architecture inside the applications. And the layered architecture started in the 70s, more or less, where we had specific problems that we needed to tackle. And I saw this really nice picture from Ted Neward, who explains that as a box cylinder architecture. And basically, the data is in a cylinder, but you don't want to access that data directly. So you have a box of logic, and that box of logic then doesn't access it directly either. So you put a box in between. And of course, there's lots of jokes out there where if you have a problem that's too complex for two boxes, you just add another box and another one and another one, and just add more layers. Unfortunately, this is still a pretty dominant architectural style nowadays, even though the type of problems that we're trying to solve is not the same, to say the least, as it was in the 70s. And a lot of these projects, and basically these monolithic projects that we've built, they turn out to become something that in domain-driven design we call a big ball of mud. And as you can see on the picture, it's not really mud, but as any big ball of mud, there's always an architect defending its creation and really proud of what it has created, really unable to see what it really is. But the idea of the big ball of mud is that the internal structure is lost to a degree where you can only really add more mud to it. And that might sound familiar. Fast forward a few years from the 70s then is, of course, microservices to the rescue, right? Microservices is the answer to any problem you have, well, except that it doesn't solve many of those problems, and it brings out its own set of problems. And I was a few months ago, I read a very interesting article, well, interesting in the, I would say the British sense of the word, like, interesting, where they described a certain way to architect microservices that sounded extremely familiar when you go back a few slides. And basically what you would have is, well, you make a big problem, you turn it into a lot of small problems, and then they're easier to solve, right? That's the idea, the big idea of microservices, and then you can change those components more easily. At least that's the promise. But if you look at every service, there are small box cylinder type applications in many cases. They have their own database. So we're solving the same problem again, but now on a smaller scale. And then we let all of these services communicate with each other to solve the big problem all together. And there's something to say about it, except that in many implementations that I've seen, and definitely in the years before I started Axon, is that a lot of these implementations turned out to really look like that. So there are services that are responsible for, let's say, the state. They're the entity services. They have this concept of a customer, and you can make modifications. But you don't want to make modifications directly to the customer. So you will have an API around it, and then some other services that are conceptually in that middle box they provide some business logic, and the services on the left, in the left virtual box, they are the backend for front end type services, right? So still there's this layer architecture that seems to want to fight its way back into the architectural style, even though we're going for microservices. And of course, I'm exaggerating slightly and then generalizing. There's different variations, but I've seen this more than once. So what we've really done is we've taken the practices that give us a big ball of mud, and we've increased the number of deployment units. And that's amazing. And then what you get is a distributed big ball of mud, otherwise known as a pile of something. And what we should be doing instead is increase the modularity. And I have to agree that on a PowerPoint slide, that is very easy. All you need to do is use boxes and happy colors, and that's it. Of course, in practice, it's slightly more complex than that. But we'll get to that a little bit later. And as soon as we have better modularity, then we can think about increasing the number of deployment units. But getting that modularity right first is very, very, very important. Unfortunately, if it was just as easy as this, we would all be building modular applications or modular monoliths and extracting components out of those and deploying them as microservices. Out there's a lot of anti-modularity forces. There's a lot of choices we make that basically drive the modularity down, and it's something we have to fight against. It is not a trivial battle that we need to fight. And in that battle, the word events pops up quite a lot. And events are very powerful. They can do a lot of things, but there's also a lot of things they cannot do, which are still attributed to them. Now, the concept of an event is fairly simple. What if you have two services and one service does something and another service needs to do something as a result of the first service taking its action, right? So service A, let's say, changes or receives a request to change the name of a customer whatsoever. It can notify service C of that change, and it can just do a call to service C. The problem is, if it's not just service C, but as the application evolves, it is also service B and D that need to know that we need to change the logic in service A to also call these other services, right? And this creates a lot of dependencies between these different services. And this is where events can be very useful, right? So instead, a service can emit an event, and then the other, the services B, C, and D can just watch those, watch whatever topic or queue these events are placed on, and then respond accordingly, right? This is a fairly common pattern, and I don't feel that I need to explain it in too much detail. However, from the arrows, you can already see that the thing that really happened was dependencies were inverted, right? Now it's the services watching a space where the other service is placing something instead of services directly interacting with each other. Now, if we take this and then look at how we can improve our microservices deployment, basically what we get is this, right? We put a service bus in the middle, and now all these services, instead of directly interacting with each other, they can just interact with an event bus in the middle. And this is very, again, very powerful, but it does not solve the problems that are very often attributed to the solution. Like, there's no dependencies that disappear. Dependencies between services don't disappear. They're now much more difficult to see, and they're inverted, but they're still there. And again, I've seen examples where you can still put the box cylinder concepts behind those services, because the services still have the same responsibilities, but their form of communication just changed. So the promise with these that are very often attributed to those events is that, well, if you want to be cloud native, if you want to be reactive, you have to use events, right? Well, that might be true, but it doesn't mean that by using events, you suddenly become cloud native or reactive or whatever it is that you're looking for. It is one of the tools in the toolbox, but you have to be very careful when to use that tool and when not to. Another thing is events give you location transparency. Well, true to some extent. I mean, by publishing an event you don't know where the consumers are. You don't know when they consume it. And that's fine. So yes, it can give you location transparency, but it can also give you very awkward coupling, as we'll see in a second. Evolutionary architecture is also something. Yeah, you can just evolve your system by adding new components that react on those events, and you don't need to change existing components. Again, it's one of these promises. And the last one is, well, if you just publish events, you can always reuse those event streams later on. You can always build a new component that goes back in time, and as long as you just keep those events around, then you'll be able to stream them to a component that was deployed after the actual first events have been emitted. Now, these are all promises, and yes, they are to some extent delivered by events, but we have to be careful to not assume that by using events we get those promises right away. Because the picture that we get is very often like a travel agency brochure, right? It always looks beautiful. In this case, there's a nice picture of a sort of a jungle environment and a beautiful waterfall. You can just feel the serenity. This is what 2020 needs, right? Unfortunately, what you get when you go there is, well, the little details. And the little details are the really annoying things that you'll encounter, but you'll never read about in advance. And I'm not going to pick all of them, but just a few that I really want to warn you about. And in many systems, what I've seen is that events are considered a side effect. Right? The system is not designed around events. They call it event driven, but it's not driven by events. It's driven by other things, by requests and state. And then events are just emitted as a side effect from whatever happens, whatever state changes are made. CDC, change data capture, is one of those examples. Like, well, we just use CDC to emit events, right? Well, that's not event driven. That's events as a side effect, and it's not per se a bad thing, but there's some aspects to be careful about. And one of them is, if you have events as a side effect, how can you guarantee that those events are correct? How can you guarantee that every change you make to a system is correctly represented as an event, and everything that is represented as an event is correctly accepted or accommodated as a change in the system as well? Right? It's that two-way problem, and that is quite hard to do. And as any side effect in your system, any afterthought that you have, like you've designed, for example, this layered architecture style application, which is very state driven. If you start doing events as on top of that, it will add complexity. Right? Anything you do that was not accounted for in the beginning will add complexity to your architecture, and that might be very doable in the beginning, but as applications evolve, that complexity just might get more and get higher and higher, and with a result that the development of new features slows down. There's something else about those events that I'd really like to talk about, and there's always things that happen in a system, or the way we talk about a system, what happens, especially when we talk to non-technical people. And the information that the system actually stores and remembers, right? The things that apparently we as developers tend to care about. And they differ quite a bit. So if we look at it, what happens is, well, an order was created. And I apologize for the lousy e-commerce kind of example, but I guess they're easy enough to just use in a presentation. So what we store is, well, we've got an order with identifier 1, 2, 3, and it's awaiting confirmation, because that's the initial state apparently. And then we added 2 items, in this case some chairs, and that's 798 euros. And then we remove a chair. And as you can see on the right, the information we store is that we just have this order, which is a waiting confirmation for one chair, which is technically correct because that's what we are trying to get confirmed at this point. But it's not the whole history. We have already deleted some information that might be interesting, might be valuable even. So the order is confirmed and the status changes. And as more events or as more things happen, I gave it away, I guess, but as more things happen, we update the status and the information we store, but the actual interesting information is on the left. It is what happened in the application. Right? That's what gives us a lot of information, whereas on the right is maybe a nice summary for some people, but we have lost a lot of information on that side. So I always start questioning, why do we store the part of the information that is less relevant than what happened? Right? So why don't we just store what happened? And this is really the concept that event sourcing is about. This is the thing that event sourcing is about not storing the current state of things, but storing how we got to that state. And I would like to emphasize that it is not about data deltas, but about capturing really what happened, describing what happened, and make sure you remember that. And as a result, you can calculate what the current state of a system is. We all know what the status of an order is given that flow that we had earlier. But I like to express the event sourcing as the way for an application to capture the truth, the whole truth, and nothing but the truth. To make sure that everything that happens gets captured as an event, and everything that is captured as an event is actually something that happened. So if it's not in the events, it just didn't happen, period, end of discussion, right? And that's something that event sourcing can give you. And when we go back to some of the challenges with events, then I really want to warn you for awkward coupling. Right? There's going to be coupling. No matter what you do, there has to be some form of communication between two components because they need to exchange information in one way or another. Right? So we just need to accept that coupling between these two components will be there. But the question is, how do we want that coupling to manifest itself? And events are very powerful, but they invert dependencies. Right? So now it's suddenly the consumers that need to be aware of the producers and producing a certain message, whereas the producer is not responsible anymore for knowing who is consuming the message. Right? And it's also a dependency that is slightly obfuscated because it becomes more difficult to find, but basically to put your finger, maybe you remember from the good old days where programming was about finding the top left part of a script, and just with your finger you could just follow the entire process of the application. With events, you can't do that anymore. As soon as you publish an event, wherever that event goes becomes really obscure, and you might need to use tools to find out where these dependencies are, which applications are actually consuming that event, and what are they doing with it. It becomes harder to track. Not problematic, but it's something to be aware of. And also, communication in terms of events becomes really awkward. You can try it at home, right? Just emit facts. It probably won't last more than an hour, and whoever else is in the home will probably go crazy, right? If you can't just shout, "I'm thirsty," and just wait for a drink to show up, right? It doesn't work like that. Communication does not work like that in between humans, and I seriously doubt it should work like that in systems as well. And that's because when we talk about messaging, while we give events so much attention, they are definitely not the only type of message conceptually that should flow between components. And I started experimenting with different types of messages, and I've fortunately, because of conferences, met other people that are also that did a similar thing, and we came down to the same conclusion. There's essentially three categories of messages, and events is one of them. And events follow a pub-sub pattern, right? An event describes a certain fact, something that happened, something that's in the past, that cannot be changed anyway. So I might as well let you know, and then you can do whatever you like based on the knowledge that the event carries. But sometimes you want to communicate because you have an intent to change something, and that's a command. And commands are typically routed to a single destination. And there might be some form of acknowledgement or confirmation from that command that, yes, we have executed what you asked for, or something like that. Right? And the other thing is, if you have a need for information, you want to ask a question. So you have a need for information, you can send a message to either to a component or have some routing mechanism route it for you. But the value of that communication is in the answer that you get. And there's different patterns that you have. You have what we call point-to-point. It's where you have a single destination, answer the question, and you've got the answer. But in some cases, you want to do a scatter-gather, which is very typical at conferences. You ask a question when you're on stage, you get multiple answers, you gather the answers, and you do sort of a reduction and say, oh yeah, half of them know about CQRS or something like that. Right? Those are different styles of queries that you can think of. But the most important is that we should not confuse eventing and messaging. An event is just an example of a message, and it is a very powerful building block, but it's not the only one. And when you use those three different styles of messaging explicitly, and you're aware of your choice when you choose what, that is when you can achieve true location transparency. Then it doesn't matter anymore whether components are all deployed in the same unit as the little box on the left, right? We have all colors in the same box, so that's our monolithic deployment. It doesn't matter as long as the queries that we have or the commands or the events that we send, they can just be published within that component. But then we can extract a component and start deploying it separately. And as long as we make sure that these messages are then transported across deployable units, then they can still communicate. And of course, there's a bit of remoting in play, so we have to be careful how we design the APIs on those messaging systems, that they are aware of potential remoting. Right? And then you can evolve as you go on. So really, the journey towards microservices should not be, oh, let's go from an idea that we have straight into, okay, this is the solution that we want to build. These are the different services that we need. Let's deploy them all separately and see where we end up. I've seen, unfortunately, too many startups with a great idea fail on all the technical complexity that they force onto themselves because they have to deal with all of the problems at day one. Right? And very often you digress, you find out that, oh, the service boundaries weren't quite right. And before you know it, you end up in that big distributed big ball of mud type of system. So instead, we should really focus on building that structured monolith first. Right? It gives us much more ability to learn about the different, let's say, sub-boundaries of our systems or boundaries of our subsystems, whatever you want. And it makes it easier to refactor those. And then as we start learning about our system and start finding out what the non-functionals are that we need to cope with, then we can start extracting components, and we can extract components for which it becomes important to do so. Instead of upfront, we thought of 5 components, we separate all 5, but now we can separate them based on the non-functional requirements that we have. And then we can evolve as we go. And that sounds all very easy, but of course we all know that there's technical complexity involved with doing that, right? Rule number 1 of distributed systems is don't, right? And it's don't for a reason, because of the complexity. So delivery guarantees become very important suddenly. Right? Within a single deployable unit, we would probably just have an in-process communication, and well, delivering a method invocation is not particularly difficult, but it does become difficult as soon as you need to cross a boundary of a process. So delivery guarantees become important. Do you want at least once, at most once? Those are basically your options, right? the timeliness. When do you deliver those messages? Do you deliver them in the same order that they were dispatched? How? That's fairly complex. How to deal with error handling, right? Things will go wrong. How do you deal with those? This is not an afterthought. This is something you want to take on from the very beginning. And then when you have these messages, how are you going to evolve them? Right? As soon as the publisher wants to change the shape of a message, how are you going to make sure that the consumer doesn't choke on that modified message structure? And how do you prevent the publisher from choking by having to maintain all versions and formats of these messages? Now that we have this promise of event sourcing, how can we trigger replays? How can we effectively do those replays for all those historic events? There's potentially millions, or in some cases billions of events. How can we replay those? How is that even a pragmatic thing to do? I'm going to keep it really short because of obviously of time. But there's tools out there, right? There's a lot of, so we started around 11 years ourselves, but we are noticing that there's a very rich ecosystem around event-driven systems for event sourcing, for concepts like CQRS and DDD. So I would definitely recommend, don't stick for too long on the things that you've known and that you've always done, right? We've always built systems like that, and it kind of works, so we might as well do the next one the same way. Make sure you keep your eyes open for new tools and new methods that are out there. But in the same time, we also need to make sure that we have the discipline to use those tools correctly, and also the discipline to not use them when appropriate. Sometimes a tool is really cool to use, but you really shouldn't. Just in case you haven't seen this one, this is a scene from the movie The Karate Kid I think it was from '84. I don't know how many times I've seen that movie back in the days, but there was one scene that I just associated directly with discipline, and it's the wax off scene. So the little boy there, Daniel, he wants to learn karate, and the gentleman, Mr. Miyagi, is trying to teach him that. And he says, well, you go wax my car first, right? Wax on, wax off. And the whole idea was to build the discipline and the muscle memory in this case to make sure that he got the movements right. And this is the basic tool that he needed essentially to win the heart of some girl in school, because it's, of course, an American movie from the 80s. So that's what the goal was. But there's a big analogy with software engineering. Sometimes we have to learn those annoying basics to make sure that we get the thing done right. And some of the practices that are now emerging they go back to the design phase, right? That's where a lot of things still, unfortunately, go wrong. So there's the practice of domain-driven design, which I can really recommend reading into if you haven't done so already. That's a book by Eric Evans, written in 2003. But I think it is more relevant right now than it was in 2003. Right? And the relevance is only increasing as microservices and distributed systems become more prevalent. But there's also some design practices that really take those events into account and start designing applications, starting at events, but definitely not stopping there. So you'll see the commands and the queries in there as well. And two of those are event storming and event modeling, looking at slightly different aspects of a system. Event storming being very suitable for exploring systems, especially if you're doing a big picture exploration. Event storming is a very good way to find out what a system should do, and taking into account that a system is broader than just the IT part of it. It's also about the human interaction with the system and even the human parts of a system. Whereas event modeling is much more about the IT part of the system, looking at how to design user interfaces, how to ask for information, where that information comes from, which occurrences of events influence those UIs, essentially. So in closing, beware of coupling, right? Events are a solution. They're a way of easing that coupling, inverting the dependencies, but don't always use that. Consider commands and queries as much as you would use events. So every time you see an event-driven system, rather think about a message-driven systems where, yes, we have events, but there's definitely not only events. And microservices are a journey, and I'm not the first one to say it, and I won't be the last one to say it, but it is definitely a journey, an interesting journey, a challenging journey, but it should start with a monolith. And most important, make sure to bring on the discipline. And if you have the discipline to do things right, you'll see that the tools that you need to use emerge quite naturally. And that, I guess, is not a pure coincidence. If you want to know more, there's a bit of time left for Q&A. And otherwise, here's a few for your references that you can use.